Hello and welcome back to another video. In this problem, we're told an electricity company charges its customers a base rate of $10 per month, plus 6 cents per kilowatt hour for the first 1,200 kilowatt hours, and 7 cents per kilowatt hour for all usage over 1,200 kilowatt hours. We're asked to express the monthly cost E as a function of the amount of X of electricity used, and to graph this function E for 0 is less than or equal to X is less than or equal to 200. Okay. So the first thing we can do is split this into two different parts. So we're writing this as E. E is equal to some certain value of the function if X is less than or equal to 1,200. If we are only dealing with the first 12 kilowatt hours, it's only 6 cents per kilowatt hour, that's a certain function. If X is greater than 1,200, then we're getting into the 7 cents usage, plus 6 cents for the first 1,200, and that's an entirely different function, so it's going to be split into two different parts. So for this first 1,200 kilowatt hours, we have the linear function, 6 cents per hour. So therefore the slope is 0.06, right? This is $0.06 per kilowatt hour. The slope is 0.06 X plus the y-intercept, right? Y equals mx plus b. Well, the y-intercept is just 0. Is just 10. The amount you're paying for the kilowatt hours is 0. So if you had 0 minutes or 0 hours, this disappears because it's 0.06 times 0, and then you're just paying the base rate of 10. If X is greater than 1,200, you're paying 0.07 cents per kilowatt hour times X minus 1,200. This is your total minutes minus the 0.06 minutes, which are covered by the lower rate. This leaves you with all the minutes left that you have to pay 7 cents per hour on. You also have to pay 0.06 cents for all of the first 1,200, and you have to pay $10 for the base fee. So this is your function for the first 1,200, and this is your function if X is greater than 1,200. We can write this a little bit clearer. Let's just simplify this first. We have 0.07x minus 0.07 times 1,200, which is 84. So minus 84, plus 0.06 times 1,200, that is 72, plus 10. This is equal to 0.076. Negative 84 plus 72 is negative 12, plus 10 is negative 2. So we have 0.06x plus 10 if X is less than or equal to 1,200, and 0.07x minus 2 if X is greater than 1,200. So this is your function E, and we're asked to graph E. I think graphing it as these lines is not super helpful. Instead, what I'm going to do is find some points for X and E of X. All right. I think the important points to do are 0, 1,200, and 2,000. You'll see why in a second. So at 0, we're paying just the $10 a month charge. We're not paying anything else. At 1,200, we're using this formula. So it is 0.06. Let's keep this separate. E of 1200 is equal to 0.06 times x, which in this case is 1200, plus 10. This is 72 plus 10, which is 82. So the value is 82. And E of 2000, we have to use the other formula, is 0.07 times 2000 minus 2. This is equal to 140 minus 2, which is 138. Okay, now we can graph E of x in the xy plane. We have E of x here and x here. So we are up to 2000 minutes on the x-axis, or sorry, hours. If I've been saying minutes, it's just hours. And we can do this as 1, 2, 3, 4. So that's going to give us 400, 800, 1200, 1600. And this is, of course, 0. On the y-axis, we're going up to 138. So maybe we can do every 20. 1, 2, 3, 4, 5, 6, 7. And then just write the values in here. Now, we have 0, 10, which is going to be halfway between 20 and 0. 1282, it's going to be at 1200 and slightly above 80. And 2138 is up here and just under 140. Now the problem with this is I'm graphing this by hand. So this is what it looks like roughly. We have a line here, and then once we get to 1200, we have a different line here. And since I didn't perfectly space these out, because you can't do that by hand, we're not accurately able to see the difference between 0.06 and 0.07 slopes, right? It's just not possible. In fact, it looks on mine like the 0.07 slope is actually less, which of course it's not. But on a graph as delicate as this, I think the only thing you have to recognize is that there's two separate line segments, which are represented exactly in the more helpful way by these right here, these two equations for these two ranges. This is your function E of x.